Stars are like giant furnaces. They burn bright, fueled by nuclear reactions in their cores. But even stars don't last forever. Eventually their fuel runs out. When this happens, gravity takes over. The star's core collapses in on itself. This triggers a colossal explosion. Imagine the biggest fireworks show you've ever seen. Now, multiply that by 1 billion times. That's the kind of energy released in a star's final moments. These explosions are some of the most powerful events in the universe. They're so bright, they can outshine entire galaxies. These spectacular events are called supernovae and hypernovae. They're not just destructive forces, they're also essential for life as we know it. A supernova is the explosive death of a star. It's one of the most powerful and luminous events in the universe, releasing more energy in a few seconds than our sun will in its entire lifetime. It's like a giant cosmic firework, lighting up the night sky with an intensity that can be seen across vast distances. These stellar explosions are not just spectacular to look at, but they also play a crucial role in the cosmos. But how does a star go supernova? There are two main ways. Each method involves a different type of star and a unique set of circumstances that lead to the explosive finale. One way involves two stars orbiting each other in a binary system. These stars are gravitationally bound and influence each other's evolution. One star, a white dwarf, steals material from its companion. This process is called accretion, and it causes the white dwarf to gain mass over time. Eventually, the white dwarf becomes too massive and unstable. When it reaches a critical mass, known as the Chandrasekhar limit, it can no longer support itself. It explodes in a brilliant supernova, releasing an immense amount of energy and scattering elements into space. The other way involves a single, massive star. These stars are much larger than our sun and have a different life cycle. As the star runs out of fuel, its core collapses under the force of gravity. This collapse happens in a matter of seconds, but it sets off a chain reaction. This collapse triggers a shockwave that rips the star apart. The outer layers are blasted into space, creating a spectacular explosion. Boom! A supernova is born. Supernovae are incredibly bright, often outshining entire galaxies for a short period. For a brief time, they can outshine all the other stars in their galaxy. This brightness can last for weeks or even months depending on the type of supernova, but their light fades quickly, over a few weeks or months. Despite their brief appearance, supernovae leave behind remnants that can last for thousands of years, enriching the cosmos with heavy elements. If supernovae are fireworks, then hypernovae are cosmic cataclysms. They're even more powerful and even more rare. Hypernovae are the most extreme explosions in the universe. Hypernovae occur when the most massive stars in the universe die. We're talking about stars at least 100 times the mass of our sun. These stars are extremely rare. When these behemoths run out of fuel, their cores collapse catastrophically. This forms a black hole. The black hole blasts out jets of energy that rip through the collapsing star. This triggers a hypernova, an explosion thousands of times more powerful than a supernova. So, how do supernovae and hypernovae stack up? They're both incredibly energetic events, but there are some key differences. First, hypernovae are much rarer than supernovae. Think of it like this. Supernovae are like lightning storms, impressive but not uncommon. Hypernovae are like once-in-a-century megastorms. Second, hypernovae are much more powerful than supernovae. They release 1,000 times more energy. Imagine the difference between a firecracker and a stick of dynamite. Finally, hypernovae produce something supernovae don't gamma ray bursts. These are intense bursts of gamma rays, the most energetic form of light. They're like cosmic lasers, shining across the universe. Section 5. After the blast echoes in space, the drama doesn't end with the explosion. Both supernovae and hypernovae leave behind stunning remnants. These remnants are like cosmic fingerprints telling the story of the star's life and death. Supernova remnants are expanding clouds of gas and dust. They glow brightly for thousands of years, illuminating the interstellar medium. These remnants are like giant cosmic sculptures, constantly changing and evolving. Hypernova remnants are even more extreme. They can span hundreds of light years, dwarfing entire star clusters. They're filled with exotic particles and magnetic fields. Studying these remnants helps us understand the most extreme environments in the universe. Section 6. Cosmic Alchemy Forging the Elements. Supernovae and hypernovae are not just destructive events. They are cataclysmic explosions that mark the end of a star's life cycle. But they also play a crucial role in the cosmic ecosystem. They're also the universe's grand recycling plants. These stellar explosions scatter elements far and wide, seeding the cosmos with the raw materials needed for new stars, planets, and even life itself. They scatter the building blocks of life across the cosmos. The remnants of these explosions form beautiful nebulae, which are vast clouds of gas and dust that serve as nurseries for new stars. Think about the carbon in your body, the oxygen you breathe, and the calcium in your bones. All these elements were forged in the hearts of ancient stars. The iron in your blood, which is essential for transporting oxygen, was created in the intense heat and pressure of a dying star. These elements weren't created on Earth. They traveled across the vast expanse of space carried by stellar winds and cosmic currents to eventually become part of our planet. They were forged in the hearts of stars. Stars are like cosmic forges where lighter elements like hydrogen and helium are fused into heavier elements through nuclear reactions. Stars are like giant pressure cookers. Under immense pressure and temperature, they fuse lighter elements into heavier ones, creating a variety of elements that are essential for life. They fuse lighter elements into heavier ones. This process, known as stellar nucleosynthesis, is responsible for the creation of many of the elements found in the periodic table. This process, called nuclear fusion, releases enormous amounts of energy. It's what makes stars shine so brightly and allows them to sustain themselves for billions of years. It's what makes stars shine. The energy produced by nuclear fusion radiates outwards, providing the light and heat that we see from Earth. When stars explode as supernovae or hypernovae, they release these newly formed elements into space. These explosions are among the most energetic events in the universe. They scatter these newly formed elements into space. The debris from these explosions enriches the interstellar medium, providing the material for the next generation of stars and planets. These elements become part of new stars, planets, and even life. The cycle of stellar birth, death, and rebirth is a fundamental process that drives the evolution of the universe. Section 7. Stellar Nurseries. From death comes life. In the vast expanse of the universe, the cycle of life and death is a constant, ever-present phenomenon. Stars, like living beings, have lifespans. They are born, they live, and eventually they die. But their death is not an end, rather it is a new beginning. The death of one star can lead to the birth of many others. When a star reaches the end of its life, it often goes out with a bang in a spectacular explosion known as a supernova. This cataclysmic event releases an immense amount of energy and material into space. That's because supernova and hypernovae can trigger star formation. The remnants of these explosions, rich in heavy elements, spread out into the surrounding space, creating the perfect conditions for new stars to form. Imagine a cloud of gas and dust floating in space. These clouds, known as nebulae, are the birthplaces of stars. They are vast, cold, and dark, often spanning light years across. This cloud is cold and dark. It drifts silently through the cosmos, a seemingly inert and lifeless mass. But within it lies the potential for new life. But then, a shockwave from a nearby supernova or hypernova slams into it. This shockwave, traveling at incredible speeds, carries with it the energy needed to disturb the cloud's delicate balance. The shockwave compresses the cloud, causing it to collapse. As the cloud collapses under its own gravity, it begins to fragment into smaller clumps. As the cloud collapses, it heats up and becomes denser. The temperature and pressure within these clumps continue to rise, setting the stage for the next critical phase. Eventually, the core of the cloud becomes hot and dense enough to ignite nuclear fusion. This process marks the birth of a new star, as hydrogen atoms fuse to form helium, releasing vast amounts of energy. A new star is born. This newborn star will shine brightly, illuminating the surrounding nebula and contributing to the cosmic dance of creation and destruction. In this way, supernovae and hypernovae act like cosmic gardeners, seeding the universe with the seeds of new stars and planetary systems. The cycle of stellar life and death ensures that the universe remains a dynamic and ever-evolving place, filled with the potential for new beginnings. Section 8. The Cosmic Dance. A cycle of destruction and creation. Supernovae and hypernovae are part of a grand cosmic cycle. It's a cycle of death and rebirth, of destruction and creation. Stars are born from clouds of gas and dust. They live for millions or billions of years, fusing hydrogen into helium and heavier elements. Eventually they run out of fuel and die, exploding as supernovae or hypernovae. These explosions scatter the elements forged in the star's cores, enriching the interstellar medium. These elements become part of new stars, planets, and even life. And so the cycle continues. Section 9. Our place in the universe. The next time you look up at the night sky, remember this. We are all made of star stuff. The iron in your blood, the calcium in your bones, the oxygen you breathe, they were all created in the hearts of stars. Supernovae and hypernovae are not just distant events, they're intimately connected to our existence. They remind us that we are part of something much larger than ourselves, a vast and interconnected universe. So the next time you see a shooting star, don't just make a wish. Take a moment to appreciate the awe-inspiring cosmic events that made our existence possible.